Uh, Welcome back again. Good
Yes,
morning,
sir.
everybody. Um, Today we are going to discuss Shirsat Microprocessor Assembly language programming. Um, Now, as far as the instruction, because what we did in chapter 1, 2, 3, 4, like if you remember, chapter 1, 2, 3, particularly, especially chapter 1, we talked about the hardware aspect of Shirsat Microprocessor. In chapter 2 and 3, we have discussed all instruction set and assembler directives rather. And chapter 4, we talked about IO interfacing. Now, as I mentioned, only left behind from the curriculum is the programming practice, right? Because since we know now hardware aspect of 8086 microprocessor, and all the instruction set, we need to understand how program can be written by using 8086 instruction set and how we can drive 8086 microprocessor. I'm not going to, because there are only 4 to 5 programs included in the curriculum, but I'm not going to look into that curriculum. Like why my ultimate target would be to make you understand how the programming aspect can be developed, like how to, what should be our approach whenever you want to develop any program. Now, whenever you want to write any program of any microprocessor, forget about 8086 microprocessor, but any microprocessor, it could be 8085 or 8086 microprocessor. First of all, you need to understand what you want to do. What is your task? Okay, what you want to do at the end of the day, right? And once you know that what you want to do or what you want to achieve using 8086 microprocessor programming, then you need to write a flowchart. Flowchart doesn't mean that, I mean, you see, like you can have the flowchart, all the symbols, you can use those symbols and see like how it can work out, right? But I'm least bothered about symbol as well. I'm talking about algorithm rather, right? Algorithm or flowchart means what should be a flow of your program, what you want to do right in the beginning, what should be like how the data can be, like whenever we are talking about the program development of any program or writing of any program, you need to understand first of all what is your target, what you want to do, and then how you want to do, right? सबसे पहले ये देखना पड़ेगा कि हाँ मुझे क्या करना है and then मुझे वो कैसे करना है, right? So first of all you need to see like, do I need, am I going to require memory locations? If yes, what is the purpose of those memory locations? Why do I need those memory locations? Number one. Then how many registers I'm going to use in the required program, right? So in that case, like whatever data you will be like how my raw data is flow is going to be, where I'm going to keep my raw data, where I'm going to keep my process data. Process data means let us say for addition of two numbers, right? For addition of two numbers, you need two numbers, right? So where you are going to store those two numbers, whether you are going to store it at memory location or whether you are going to store at internal registers, right? This is number one. And what is the value of data as well? Because you know, like if you are having huge amount of data, that data cannot be stored in internal registers. Then you need to use memory, right? You need to use memory locations to store that data if you are having huge amount of data. But if you are having only one or two data byte, then that could be stored in internal registers, right? So that you need to first of all tackle out on paper. You need to write what kind of data I'm going to have, right? And what would be like manipulation of data. First of all, you just work it out on your paper and then start writing. Okay, so then similarly, like once you have the destination for your raw data, similarly you need to work out what would be destination my process data. Process data means whenever I'm executing program, I'm going to get the process data. It could be the addition, it could be sum, it could be difference, it could be product, whatever, right? So the process data, you need to see like where I'm going to keep my process data as well. So first of all, you need to see like what is my raw data is all about, where I'm going to keep it, and what is the process data is going to be all about, and where I'm going to keep it at the after execution of program. And then you need to understand like how many registers you will require for writing that program, because we know we are having limited number of registers, right? We are going to have only 4 16-bit register, or if you want to make it as a 8-bit register, then you are going to have 8-bit registers. And then there are some special purpose registers as well, but you need to understand like how many registers you will need during execution of program. And if it is the case, like if you need more than 8 register, 8-bit register, or more than 4 16-bit register, then you may need to use push and pop instruction in the program as well. Push and pop, what is the purpose of push and pop? Because push and pop instructions will allow you to push the content of the current register into the stack memory, so that that register can be made available for processing. जैसे कि आपके पास बहुत सारा data है, so what, and you need more than 8 bit register or more than 4 16-bit register, तो आपको क्या करना पड़ेगा, उसका जो कंटेंट है वो स्टैक मेमोरी पे आपको पुश करना पड़ेगा फॉर टाइम बिंग, एंड देन दैट रजिस्टर मे बी मेड अवेलेबल फॉर प्रोग्रामिंग, एंड देन मेक यूज ऑफ दैट रजिस्टर. Once your work is over, again pull that data back from stack memory to the respective register. So you need to use push and pop instruction as well, right? So this is the overall idea I'm giving you, so that everything need to be work it out on paper, so that it will be easier for you to write the program. Now I don't want to make it very difficult, and therefore I would like to start from very simple program. You can see a simple program to increment an 8-bit number. So you have to write a simple program to increment an 8-bit number. Now this is going to be a standard format of assembly and machine language programming, right? Because it consisting of both assembly code as well as machine code. So whenever you will be writing program on microprocessor kit, then you will find this kind of format of your program, right? What does it consisting of? The first column would be address. Address means the memory location where you would like to keep this program. And then second would be machine code for this instruction. Third column would be label, and fourth would be mnemonics. Mnemonics means the assembly code. Mnemonics means assembly code. And then last column would be comment. Comment means what is the interpretation of this. Now since we are not going to have machine code here, because our ultimate target is to understand assembly language program, and therefore what I did, I kept these 3 columns empty, at least specifically 2 columns empty. But since this is a very simple program wherein we don't have any label, so we are not going to have anything in label column as well. But depending on the situation, whenever the complexity increases, you may use this label column as well. But as address and machine code, these 2 columns are going to be when empty forever as far as this teaching is concerned. But whenever you will be doing practicals, obviously you need to have machine code. That is why what we need to do is you will have to write this program on assembler. Then assembler will provide you machine code. You can write it here and then put it on. Then you can use microprocessor kit to execute your program. So difference between microprocessor kit, like whenever, because of this pandemic, you could not do your practical, but like once the pandemic is over, or maybe from next month we may have the classes. So during whenever you will be coming to the lab, there you are going to have same experiment on microprocessor kit as well as assembler. So whenever we are talking about assembler, then there you will be feeding only assembly code, because assembler will take care of conversion of your assembly language into machine code. And then you will be having machine code. You can write it down here, and then if you want to execute the same program on assembly, the microprocessor kit, then you can feed only machine code. There don't need to feed mnemonics, because there is no option as well. You will have to feed machine code, because the microprocessor kit requires only machine language. It cannot accept the assembly language because it doesn't have assembler. Okay, so in order to understand the microprocessor kit as well as assembler functioning, we are going to have the same experiment on microprocessor kit as well as the assembler. Okay, let us start with the first program. You can see what is the purpose. Purpose of this program is increment an 8-bit number. So what is the purpose? Purpose is you will like to have a program, you will like to write a program which will increment 8-bit number. So it means you have got only one data item that need to be incremented. So for that purpose, you need only one register. You need only one register. You can see a very simple program. MOV AL05. This will take this 05 into AL. Next instruction would be INC AL. Increment AL. That's it. So this program will have only 2 lines, only 2 instructions. This is the program, this is the assembly language program which will increment 8-bit number. Okay, so what we did, we have used only one 8-bit register. You can use any, because we have got option of using any of 8-bit 8-bit registers: AL, AH, BL, BH, CL, CH, DL, DH. Okay, so this is very simple program. MOV AL05. It means move 05. You can see comment, move 8-bit data 05H into register AL, and then increment AL. INC AL means increment AL. That this is the purpose of this program, and this is what. Second program is going to be increment 16-bit number. Now, since it is 16-bit number, we need, what is requirement? My requirement would be, instead of 8-bit register, now I will be using 16-bit register. So we are having 4 16-bit register: AX, BX, CX, and DX. So I am using here AX. So MOV AX 0005. So you can, any 16-bit number you can take. This is just an example. Okay, right from 0000 to FFFF. Any number you can take. So move this 16-bit data to register AX. Next instruction would be INC AX. So instead of AL, now it is AX, because we would like to increment 16-bit number. So we have chosen 16-bit register. So this is another program which will increment the 16-bit number. That's it. Let us go to third program. What is third program now? Just like increment, we would like to decrement 8-bit number. Okay, so this is program which will decrement 8-bit number. Now, what is how again, like since it is 8-bit number, you will need only 8-bit register, right? So MOV AL05H, it means move this given 8-bit data register AL. The next would be DECAL. That's it, decrement AL. So that is this is how this program can be written. Program 4, this will get the decrement of 16-bit number. So now, like 8-bit number, now we have considered 16-bit, 8-bit register. Here we have considered 16-bit register, because we would like to decrement 16-bit number now. So you can see MOV AX 005H and then DEC AX. That's it. So DEC AX will decrement the value of content of AX by 1. So this is the purpose of program number 4. Let us go ahead. Now write a program to get 1's complement of 8-bit number. 1's complement of an 8-bit number. So now again, single data item. So you need only one register, and you need to identify instruction which will get the 1's complement of the number. We know in 885, 886, we have got not instruction. Not instruction will give you 1's complement of the given number, and therefore there are only 2 instructions will be required here. MOV AL05H, which will take the 05 into a register AL, and then not AL. Not AL means it will take 1's complement of the content of AL. So this is simple program which we have written to get 1's complement of an 8-bit number. Now, if I ask you to write a program get 1's complement of a 16-bit number, what you will be doing? You will be replacing this 8-bit register with 16-bit register, and the instructions are going to be same. MOV AX 0005H. It means this 0005H will go to register AX, and not AX will give you 1's complement of your given number. Next, 7th program. Now let us see, like you have been asked to get 2's complement of 8-bit number. So first of all, you need to understand what is 2's complement. 2's complement is, we know it is very simple, like 1's complement plus 1. So you will have to take 1's complement and then you have to add 1. So you see how simple it is going to be. Now we know we have got, like, what is the requirement? The requirement is you are going to have single data item, and you will have to take 2's complement of the given number. So what you need? You need one instruction which will take that number into that desired register. Then second instruction will be required to get 1's complement, and third instruction will be required to get add one to that 1's complement number. That's it. So there would be only 3 instructions required. You can see MOV AL05H, which will take the 05H data to register AL. Not AL will give you 1's complement of AL, and then increment AL means 1 would be added. So this is what the 2's complement means. 1's complement plus 1 gives you 2's complement. So the only 3 instructions are required to write a program to get 2's complement of a given number. Now, next program is 2's complement of a 16-bit number. Now, whenever we are talking about 2's complement of a 16-bit number, again, same program would be same. Only we need, since we want to get the 2's complement of 16-bit number, we want 16-bit register now instead of 8-bit register. So here you can see we have considered now 16-bit register MOV AX 0005. So this data can be any data, right? Then not AX will provide you 1's complement of the given number, and then increment AX, one will be added to the number that will provide you 2's complement of the 6-bit number. So this is how we started. Like I thought, like let me show you the very simple example to begin with, and then slowly we are increasing the complexity now. You can see now this is addition of 8-bit number. Now, right? We would like to write a program to get addition of 8-bit numbers. Now here you can see here we would like to have a program which will gives us addition of 8-bit number. It means you are going to have two data data item, right? So it means you need 2 registers. Now since it is 8-bit, I need only 8-bit register, so I have chosen register AL and BL. So what would be my first instruction? First instruction would be MOV AL, 05. It means 05 will goes to AL. Second instruction would be MOV BL03. Second data byte, second 8-bit number is going to be stored in BL. हमने क्या किया? पहला नंबर AL में रख दिया, दूसरा नंबर BL में रख दिया. Now what is next? Get the addition. That's it. We know the very simple instruction: add AL, BL. Add AL, BL means content of BL will be added with AL and result will be stored in AL. That's it. So this is a simple program which will gives you addition of 2 8-bit numbers. Now similarly, if I ask you to write addition of 2 16-bit numbers, then what would be the difference? Difference would be, instead of this 8-bit registers, I would like to have 16-bit register because my data item is 16-bit now. And then instructions would be MOV AX 0005. I mean, this is just an example, right? Because repeatedly I'm taking same data item. It doesn't mean that every time you need to have the same data. It could be anything from any data item from 0000 to 1FFFF, any data item, right? So MOV AX 0005H, which will take this first number into register AX, MOV BX 0003, which will take second number into BX, and next would be add AX, BX. That's it. Now let us go for next program. What is that now? Now we have considered addition. Now this is subtraction of 2 8-bit numbers. So again, since we are having only 2 numbers, you need only 2 registers, and that too subtraction of 2 8-bit numbers. So MOV AL05, MOV BL03 is same. Only instead of add AL, BL, it would be subtract AL, BL. This will provide you subtraction of 2 numbers. I mean, BL will be subtracted from AL, result would be AL, right? Now, next program is subtraction of 2 16-bit number. This is subtraction of 2 8-bit number. This is subtraction of 2 16-bit number. Whereas here, instead of only 8-bit register, we are going to consider 16-bit register. Rest of the thing will be the same. Next is now multiplication. Multiply 2 8-bit unsigned number. 2 8-bit unsigned number, because we know there is the instruction which will have the multiplication of unsigned number as well as signed number. There are 2 different instructions, right? Now here, now since we are going to have the multiplication of 2 8-bit numbers, so you know, like there will be 2 registers required, and then you need to understand what is the format of multiplication. I mean, which instruction can be used for multiplication of 2 numbers. And we know MUL followed by register, MUL followed by register. This is one of the instruction of 8086 microprocessor, which will multiply the content of BL with AL. So here MUL BL, in this case, your multiplicand, yes, multiplicand is always going to be in the register AL by default. And therefore what I did, I have transferred my multiplicand into register AL, MOV AL05, and then MOV BL03. So second multiplier is going to be transferred to BL, and next would be MUL BL only. That's it, nothing else. This will multiply BL with L, but remember your products would go to AX. So this is the format of MUL BL instruction. By default, in multiplication instruction, by default, your multiplicand is always going to be in AL, and therefore whatever number you would like to have as a multiplicand, that need to be loaded into register AL. That you need to be very sure about. Next program would be to multiply two 8-bit signed numbers. So this was for unsigned number. This is going to be for signed number. So what would be difference? Difference would be you can see instead of MULBL, it is going to be IMULBL. That is the only difference. IMULBL is going to take care of multiplication of two signed numbers. So we have already discussed difference between signed numbers and unsigned numbers, and this while considering a multiplication instruction, arithmetic instruction, multiplication arithmetic instruction, we have already discussed how this can be processed, right? So the difference between signed and unsigned multiplication would be, in case of unsigned number of multiplication of unsigned number, you will be using MUL BL instruction. This can be, it need not be BL. It could be MUL, CL, DL, anything. The only difference would be the every time that to be. That you need to remember every time. But multiplicand would be always in register AL. Now let us go to next. So next would be now, because we have discussed multiplication of two 8-bit number, 16-bit number. Now let us discuss multiplication of two 16-bit unsigned number, because this was, you can see, this was multiplication of two 8-bit unsigned number. Now this is multiplication of two 16-bit unsigned number. Okay. Now since it is 16-bit, you need to understand what is the instruction, right? So again, you need two 16-bit registers. So I'm going to consider AX and BX. So MOV AX0004, that will take this number to AX. MOV BX0003, that will take second number to BX, and MUL BX, that's it. MUL BX means the content of BX will be multiplied by AX, and result would be in BX AX. Because whenever you are having 16-bit multiplicand and 16-bit multiplier, your product may be more than 16-bit. And therefore, by default here, your product is going to be stored in BX and AX. BX means your higher word. Your higher word will goes to BX, and lower word will goes to AX. So this is how this program is going to be. Now let us go to next program 16. Now this is 8-bit division of unsigned number. Now, so this was like multiplication. Now this is division, right? Now whenever we are talking about, because as far as division is concerned, if you remember, there are two different instructions. One is 8-bit division of 8-bit division, other is 16-bit division. Now whenever we are talking about division, there will be four different numbers. One would be dividend, other would be divisor. I mean डिविडेंड मतलब क्या है कि जिस नंबर को हम डिवाइड करते हैं उसको डिविडेंड कहते हैं, जिस नंबर से डिवाइड करते हैं उसको हम डिवाइजर कहते हैं. And in results you are going to have quotient and remainder, right? So therefore, first of all, you need to understand 8-bit division instruction. Let us say DIV-BL. What is the DIV-BL is all about? Here, our by default, your dividend is going to be in AX. By default, your dividend is going to be in AX. And divisor can be in any 8-bit register. Like DIV-BL means your dividend will be in AX register and your divisor would be in BL register. As far as result is concerned, quotient will always go to AL by default and remainder will go to AH. Okay, this you need to understand. And now what I understood now, whenever I am using 8-bit division, my the content of my dividend is going to be in register AX. So what I'm going to do, I'm going to use this instruction MOV AX 0004, right? This is going to my dividend. This goes to 8-bit 16-bit register AX, because this is by default I'm going to have my dividend in AX. Now as far as the divisor is concerned, I can use any 8-bit register. Let us say MOV BL02. So this divisor will go to register BL. And then next instruction is very simple, div BL. It means the content of AX is going to be divided by BL, and result is going to be in the form of quotient and remainder. Quotient goes to AL and remainder goes to AH. So these are three different instructions which can be used to write down program for 16-bit unsigned number. I mean division of 16-bit unsigned number. Then 16-bit division of unsigned number. So this was 8-bit division, and this is going to be a 16-bit division. Now 16-bit division means your divisor is going to be 16-bit. Dividend is going to be 16-bit. Divisor is also going to be 16-bit, right? Whenever we are talking about divisor, right? Whenever you are talking about 16-bit divisor, in that case, what will happen now? Your result is going to be different. I mean, as far as result is concerned, your quotient goes to AX and the remainder goes to DX. So this is only the difference. And since it is 16-bit division, I need DX register also 16-bit. This would be same like MOV AX, any number, MOV AX 000C. It means the first number will go to register AX, and my divisor, second number, will go to BX. Okay, and then div BX instead of BL, div BX. So what will happen then? Here the content of AX is going to be divided by BX, and in result quotient goes to AX and the remainder goes to DX by default. Let us go to now another program, right? This is something little bit bigger program. Now because I started from very simple program, now I'm going to show you little bit bigger program. What is this? Write arithmetic language ALP, arithmetic language program, to get addition of two 8-bit numbers, but now it is going to be a little bit more structured way. Those two 8-bit numbers are stored at memory location 1000 and 1001. Now I am specifying, right? पहले क्या किया था मैंने कुछ specify नहीं किया था. Now here I have specified that your raw data, I mean two numbers which you are going to add, those numbers are stored at two different memory location 1000 and 1001 respectively. And I want you to store your carry and carry at 1002 and sum at 1003, because whenever you are doing addition, you may get carry as well, right? You may get carry as well. Whenever the result, whenever there will be like carry generated from MSB, it may cross the I mean if it is 8-bit addition, it may be more than 8-bit as well, right? So I want you to store your carry at memory location 1002 and sum at memory location 1003. Okay, now you can see how I have done this program. Now since because I want that carry to be generated, right? First of all, what I'm going to do now, you have to do some preliminary rough work on paper. तो क्या होना चाहिए? तो मुझे सबसे पहले डिसाइड करना पड़ेगा कि मेरा जो कैरी है वहां where I'm going to do which register I'm going to use for generating carry, right? Because if it is there, if it is carry generated, I need to increment that. I need to have a logic 1 to be stored at the respective memory location. Which memory location? 1002, right? Therefore, what I am going to do here, मैंने decide किया कि CL register I am going to use to indicate the carry. Okay, so but before that, what should I do? I need to make it 0, क्योंकि पहले अगर 0 मैं नहीं करूंगा तो क्या होगा? उसमें जो भी पहला स्टेटस होगा उसमें 1 ऐड होगा. जब कैरी अगर आती है तो मुझे खाली 1 आना चाहिए, लॉजिक 1 आना चाहिए. तो मुझे क्या करना पड़ेगा? उसमें CL को मुझे 0 से इनिशियलाइज करना पड़ेगा. Therefore, what I did here, MOV CL 00H. Okay, and then MOV SI 1000H. So MOV CL 00H. Why MOV SI 1000H? Because here, yes. Pardon?
Example घेऊन सांगता का?
I'm going to explain this because maybe after 2-3 minutes this session is going to be terminated. Then we are going to have question answer session, right? So here this you see here MOV CL 00H. This 0, I mean your counter is going to become, I mean CL is what will happen? You can see the comment as well, right? MOV CL 00H means your CL is going to be initialized with 00, right? Next is MOV SI 1000. Now why SI? Because we know SI is source index register, DI is destination index register. I want my because my numbers are stored at 1000. So what I did now, I need to initialize SI with 1000 because my raw numbers are stored at these two 1000 and 1001. Therefore, what I did now here, I have initialized source index register with 1000. So MOV SI 1000H. This will initialize SI with 1000, and then MOV AL comma square bracket SI. What does it mean? It means that the content of memory location whose address is in SI would be transferred to AL. इसका मतलब क्या होगा कि जे 1000 पे जो डेटा है, that data is going to be transferred to register AL. So first data item I could transfer to AL, right? Now my next data item is at 1001, right? Therefore, what I need to do, I need to increment SI by 1. So therefore, I have used INC SI. Okay, so INC SI will help me to increment my content of SI with 1000 with 1. So it means that now I got 1001 memory location where I am having second data item, right? And therefore, I have used instruction MOV BL square bracket SI. It means the content of address, content of the memory location whose address is in SI will be transferred to BL. इसका मतलब क्या हुआ कि मेरा second data item मैंने BL में लिया. So first data item I got in AL, second data item I got in BL. Now next job is to get the addition. Add AL comma BL. That's it. Okay. Now whenever I am doing addition, I need to check whether, because यहाँ पर मैंने लिखा है कि carry should be stored at 1002 and sum should be stored at 1003. So I need to check whether carry has been generated, right? And therefore I have used this instruction. Jump if no carry to next. Jump if no carry to next. अगर carry अगर नहीं आती तो मुझे क्या करना है? CL को increment करना ही नहीं है, CL को 00 ही रखना है. अगर carry अगर आता है तो क्या हुआ? Jump if no carry here. But if, because इसका मतलब क्या है? Carry अगर नहीं है तो this is going to skip. The program is going to be transferred to next location, next label, right? What is next? Increment SI. Jump if no carry, increment SI, and then no, this should not be increment SI. There is this is wrong. This should not be increment SI. Yes, yes, this is increment SI because I want to store my like carry at 1002. यहाँ पर क्या हुआ मेरा, what is my SI? SI is at 1001 only. My SI is at 1001. I want to store my carry at 1002. So I need to increment SI by 1 so that my SI is going to be 1002 now. Okay, and then MOV square bracket SI comma CL. So content of CL will go to SI. So CL मेरा क्या था? 0 था, because carry नहीं है, इसका मतलब मेरी carry 0 रहेगी. That goes to SI. SI means what is 1000? 1002. इसका मतलब 1002 पे मैंने क्या स्टोर किया? 0, जो कि carry आई नहीं. And then increment SI. Again, increment SI means increment SI to get 1003. Now I want to store my sum at 1003, and then next would be MOV SI AL. AL में मेरा sum है because add AL comma CL. इसका मतलब add AL comma CL का मतलब क्या होता है? Content of AL is going to be added with AL. Result is going to be stored at AL. So मेरा result कहाँ पे? Sum का है, AL में है. That goes to SI. SI means 1003. Because what is the meaning of this instruction? Content of AL is going to be transferred to the memory location whose address is in SI. I have अभी SI में address 1003 में मेरा sum चले गया. And then next instruction is, last instruction is this halt. Halt means terminate the program. My job is over, right? It means what I did, I mean develop a program which will have addition of two numbers. Those numbers I have taken from very specified location 1000 and 1001, and the carry I have stored at 1002, sum I have stored at 1003. So this is like earlier I have developed one program that gave me the addition of two numbers with very simple form. But here it has been very specifically specified that those raw data is where are in 1000 and 1001. So now you have to write a program to take that raw data from two different memory location, add it and check whether you have got carry. If carry is generated, store it at 1002. and some, if not, it would be like, if it is generated, it should be 1, if it is not, it should be 0, right? And store the sum at 1003. यहाँ पर देखिए, अगर if JNC मींस कैरी नहीं आई तो यहाँ जाएंगे हम, कैरी अगर आई तो क्या होगा, इंक्रीमेंट CL में हमने क्या किया था, 0 किया था, that will become 1. कैरी अगर आई तो it will become 1, right? So this is how this program has been developed. Now what I'm going to do very soon, this is going to be terminated now.